So for the differentiation of hyperbolic function, we have our formula number 29. Now that the hyperbolic sine u, the differential of hyperbolic sine u is equals to the hyperbolic cosine u du dx. And for the differential of hyperbolic cosine u is equals to the positive hyperbolic sine u du dx. And for the differential of the hyperbolic tangent u is equals to the square of the hyperbolic secant u du dx. And for the hyperbolic cotangent u is equals to the negative of the square of the hyperbolic cosecant u du dx. And for the differential of hyperbolic secant u is equals to the negative hyperbolic secant u tangent hyperbolic tangent u du dx. And for the differential of hyperbolic cosecant u is equals to the negative hyperbolic cosecant u hyperbolic cotangent u du dx. So we have these 6 formulas for our hyperbolic function. Your background in trigonometry, where you have studied hyperbolic function, will help a lot in addressing for the differential or for the differentiation of hyperbolic function, where we can use that the hyperbolic sign is also equal to the e to the x minus e to the negative x all over 2. And for the hyperbolic cosine x is equals to the e to the x plus e to the negative x over 2. And for the hyperbolic tangent, cotangent, secant, and cosecant is the same principle applied for the trigonometric function, where tangent theta is equals to sine over cosine. For the cotangent, it is cosine over sine. For the secant, it is 1 over cosine. And for the cosecant, it is 1 over sine. Just add the adjective hyperbolic. Now, with that, as you notice, the square of the hyperbolic cosine minus the square of the hyperbolic sine is equals to 1. Also, for the square of the hyperbolic tangent x plus the square of the hyperbolic secant x is equals to 1. And also, the square of the hyperbolic cotangent x minus the square of the hyperbolic cosecant x is also equal to 1. And for the hyperbolic sine 2x is equals to 2 hyperbolic sine x cos hyperbolic cosecant x. And the hyperbolic cosine 2x is equals to the square of the hyperbolic x plus the square of the hyperbolic sine x, or it is also equal to 1 plus 2 the square of the hyperbolic sine x, and it is also equal to the 2 times the square of the hyperbolic cosine x minus 1. So all these things will help a lot in the interpretation of any problem involving hyperbolic functions. Okay? Find dy dx if y equals the hyperbolic sine of 4x plus 3. So to solve it, you have to apply the hyperbolic formula. So y equals hyperbolic sine of 4x plus 3. So our dy dx now is equals to the hyperbolic cosine of 4x plus 3 times the differential of 4x, it is 4. We have now 4 hyperbolic cosine of 4x plus 3. That's your answer. Find dy dx if y is equals to 3 hyperbolic cosine square 4x. So again, we have y equals 3 hyperbolic cosine square of 4x. Our dy dx now, as you notice, this is power. So you have 2 hyperbolic cosine 4x. Differentiate now this one, we have hyperbolic sine of 4x times differentiate the 4x, we have the 4. So we have now 4, 6 times 4 it is 24. Hyperbolic cosine of 4x and hyperbolic sine of 4x. Express now this in this term. So we have 12 times 2 hyperbolic sine of 4x hyperbolic cosine of 4x. So as you notice, this is 4 divided by 2. We have now 12 hyperbolic sine of 8x. So 8 divided by 2, 4. So this one, half of this. So 4x, 8x.